Hi everyone. Welcome back to our series of building generative AI platforms in which we were discussing the blogs from Chip Huan, who were earlier professor at Stanford for machine learning system design and have been doing a lot of great work when it comes to AI and ML system design. So in this part of the series, we have been learning how to build or design the generative AI platforms. And this is second part of the series that we have already started earlier. Now, to just give you for the people who have not seen the first part, I would recommend you to please go back and watch the first part. And just to give a brief glimpse of what we did in the first part is for the architecture that we are trying to develop, this complex architecture, we tried to build it from the scratch from using the one of the most simplest component in which we were just using the query, the model API, and then finally generating the response. Then we saw that if we do the context construction, we can definitely improve the quality of the results that we can get from our model. And for that, earlier the first we use the how we can use RAG or retrieval augmented generation to improve the search results. Then we also see through like how we can integrate agents using the read-only actions to improve the context construction and which in hand will improve the final response that we are generating. So in this particular session, let's dive deep and continue from there. Yeah. So second step was in our use case was the guardrails, putting in the guardrails. Now, particularly to understand why we want to put in guardrails is, for example, if a user comes and it asks my model to do some sort of different things which the model or the chatbot is not allowed, and since the model doesn't have intelligence of its own, a lot of times these models can be tricked into doing something that is unethical or maybe not right on the part of the company who has built these AI services. A lot of times, the user might feed the company's confidential information, which might leak the secrets. And this thing kind of happened. There are a lot of incidents, and one of the incidents that became famous was Samsung. A lot of Samsung's employees put the confidential or the proprietary information into ChatGPT, and which leaked some of the secrets of the company. And because of this, the Samsung has to ban ChatGPT, and it has an impeccable impact on the company when it comes to its brand and how it functions. So to eliminate all these kind of potential problems, we try to put in guardrails. And in this particular the guardrails could be very complex as to how different companies design, but generally in a very, if you try to understand in a simpler way, people try to put in two kinds of guardrails. First are the input guardrails, in which before putting into the data into the LLM or the models that we have, the third party models or the in-house model, we generally try to mask the personal information, the personal faces, specific keywords and phrases which are associated with companies' IPs or privileged information. And now I think this has been a very common industry practice, and there are a lot tools out there which can detect these things and mask these on our behalf. And you might be asking one thing. For example, if I have this user query and this particular thing, pet. Now I can mask this particular pad by the SS token, and in the reverse and in I can create, and you might be asking one question. If I mask this thing, then when I have to return the answer to the user, how can I do something like that? Because I don't know what was behind that particular mask. So in this thing, we designed something called as reversible personal identifiable information map, in which we store whatever masking we did as to X. If we write access token, then this was what it was written in place of it earlier. And then finally, once the user gives the query, then it is masked. Then the model works on that thing and gives a response. Now, the model response is taken and we do an unmasking response thing. Based on this thing, we can mask, we can build an input guardrail which stops giving personal information to the model. If it can block, it does block. If it shouldn't block, then it tries to mask that information. The second thing is a lot of times people try to jailbreak the model. For example, NoSQL queries that can insert, delete, or update data, which can be executed without human approval. It could take a lot of harmful action. And the downside, so we need to control these kind of things. And one of the issues is by adding these sorts of guardrails, one of the downside is it does slow down a system. But this is like what we have to do is we have to stop these things because system going wrong is generally considered very bad as compared to we increasing time on the latency of some of the wrong things that are being asked for a model to do. Then after input guardrails, we have the concept of output guardrails. These guardrails are in a similar sense. So if our model has generated some response, then we can evaluate the quality of each generation, specify some of security policies to deal with different failure modes. Now in this thing, for output quality measurement, it could be a very qualitative term. But some of the things we can see to make sure like how we can improve the quality of our output. The first is if we have empty responses, we can return something that we are not able to generate. A lot of times, the responses that we get from LLM are malformatted, such as if we want JSON and it generated a JSON without missing closing bracket. And if we're giving that output of JSON to some of the function which might run directly, then it might fail. So we can have these code validators or format validators to make sure we are getting everything within the right thing. The third is toxic response. A lot of times, even the user fed something which shouldn't be fed, and if our model generated toxic response or maybe hallucinated or some biased response, similar to what might have happened in case of when the Google released the Gemini for images earlier, it got down a lot of bad branding on the Google, and we need to control those kind of things. Output quality, output guardrail is one of the things that can take care of that thing. Then a lot of times, model has needed generates factual, inconsistent responses, and there are a lot of things, or maybe algorithms, or maybe you can say practice into play to improve that thing. And one of the techniques which is very well used is the chain of thought. A lot of this topic could be dealt into a very deeper discussion, and I think which is outside the scope of current discussion that we are having. And then we have a lot of times our response that contains sensitive information, maybe a salary of some particular person, which shouldn't be given to any other person without anything, without any credential check or something. So we need to see if it contains some sensitive information. We need to block that sensitive information to go out of our system. Then a lot of times we have brand risk responses. So for if we give an example, when the Grok was released by X, then it generated a response that suggesting that Grok was trained on OpenAI, and all over the internet it was famous that Groks used the OpenAI's data. It might not have been used, but this is what model has generated, and uh, which got a lot of questions to the brand image of that particular system. Then finally, we have a lot of times our LLM generating really bad responses, and in that the answer to be the user query might be wrong, and because of that, the model generated bad response, which shouldn't be even if it's too bad, it shouldn't be shown to the user, and we should make some sort of output guardrails to stop those things to be given back to the user. And a lot of times, all the models that we have are probabilistic. And if we try to query again, we might get a different response. And a lot of the failures that we have discussed till now, uh, these can be mitigated if we try to have a retry logic. For a lot of times, what we can do is at the same time we do two model tries and we try to evaluate the better output that we get, we give it to the user. However, in this times, what we can do is if it's a sequential process, we can do two API calls, which might increase the latency, or we can run these thing in parallel processing or multi-processing and then compare the outputs. It might increase the cost that we have, but at the same time, most probably it's going to increase the output or the probability or the right things that we can, the output quality that we have. Finally, we have because of guardrails, we do have a lot of trade-offs. But there's one trade-off, the most important trade-off that we see through is the reliability versus latency trade-off. In this, while we know that using these guardrails increases the reliability of the model or the outputs or the inputs that we have, yet at the same time, it's increasing the latency. And this is a trade-off, and mostly I think organizations go with the reliability as compared to the latency thing. And one of the other aspects is the output guardrails might not work well with the stream completion mode because generally the whole response is generated because if I want to put an output guardrail, I have to generate the whole response and then run some sort of guardrail on that before I can show the output to the user, and which might take a lot of time. In stream completion mode, this thing it's very hard to put in the output guardrail. And the downside of this thing is if I have a partial response, it's very hard to evaluate partial response. Or a lot of times you lose the context if you have the partial response. Then the second thing is which a lot of organizations are very prone to think is self-hosted versus third-party API trade-off. And a lot of times, if most of the models, if the organizations that they are using are these bigger companies, LLMs, and these companies don't want their data to be leaked or to be used by someone else for their use cases because this was the guarded information. And for that, these companies put in a lot of input guardrails. But what a lot of companies also try to do is they try to take off most of these open source model into their in-house infrastructure that they have, and then there might not be a need of so many input guardrails because all the data that you have would be within your infrastructure only. So this is a trade-off, uh, because you won't have those bigger or maybe more powerful models, yet at the same time, the safety or reliability that you want, you can easily have that. So I think thank you very much for sticking till here, and I think you were able to understand. First of all, why are we putting in the guardrails in the first place? Second, if we put guardrails, we can have input and output guardrails. What are different metrics of what are the ways we can think through while putting the input guardrails and the output guardrails? And then finally, the trade-off. And in this thing, earlier what we were doing is just the model API generation using the model API. Now what we can do is we can generate different sets of output and put a scoring mechanism into the place, which gives finally through which finally our application gives the best generated response out of it. So yeah, that was it for this session. And if you really understood something and gained something, please don't forget to like, share, and subscribe. Thank you and see you in the next session.